Okay, so let's talk about the actual data messaging. So as far as the data messaging, the protocol that we use is called RTMP. The actual implementation of it is done through tunneling. So the phone will communicate with the backend through a tunneled HTTP-based protocol, and all the data is going to be encoded into binary format. There are a lot of benefits to using that protocol, and the core benefits really include ability to invoke server-side functions from the client, being able to invoke client-side functions from the server, using remote shared objects, and we're also working on adding video and audio streaming, which is part of that protocol. And that will enable recording and broadcasting of the video directly from the phone through our server, both with Java and .NET. Okay. Let's see. Now, I have a couple of demos that I want to show you. So let's start with the first one, which is the remote shared object. Now, if you're not familiar with remote shared object, what that is, you can think of it as a hash table which resides on the server, and it has a logical name assigned to it. You can have as many clients as you want connecting to that particular remote shared object, and it really works just like a hash table, meaning that various clients can just update properties in that remote shared object by just using the APIs that we provide. The real magic happens is once you update the actual remote shared object. What happens is you update one of the properties and put some object in there, and then the server will automatically broadcast this change to all connected clients. And as a result, you could have various phones all connected to the same remote shared objects, quickly notified that a particular change has occurred, and thus they can quickly and easily communicate with each other. And that update may be initiated either on the client side or on the server side. So you can broadcast changes through those remote shared objects from the server to all connected clients. And as far as the client support, we are working on expanding it to both iOS and Android devices. But as far as Windows Phone 7, it is ready today. So let me show you a demo of using remote shared objects. Hopefully we'll have better luck with that than with our remoting. All right, so here it is. Just a few words about the actual API. So first of all, once again, we use the WebORB client API and specify the URL of where it's going to be connecting to. I will need to update it to use my computer. And this is the name of the server-side application that is hosted inside of WebORB. And you can just sign up for various events. So whenever a connected event occurs, we're just going to invoke this particular method, and then we connect to that particular application. Once it is connected, then we can sign up to we're basically adding a callback whenever this shared object is updated, and it's updated object handler. And inside of it, there's the logic of this application. So let me quickly compile and run this app. And to demonstrate this, what I'm going to do is I will run a Flex-based client that connects to exactly the same application. So for this, let me bring it up. All right, so here's my Flex client. Now notice that on this client I have on this particular page I have two different Flex clients. So notice that as I move this sphere around, the actual sphere is moving on the phone as well. All right, and the same thing can be done if I were to move the sphere on the phone, and then as you can see, it is automatically replicated in the actual Flex client. So here it is, and this is happening in real time. The way this works is then when I drag the sphere, let's say in the Flex client or in my Windows Phone 7 client, it updates the coordinates of this sphere in the remote shared object. And as a result, WebORB automatically pushes this data to all connected clients, which is, and then I can actually start another one, and it will work exactly the same way because they're all connected to the same remote shared object. So you can see I'm dragging it on the phone, and everything else is synchronized. Okay, so it's a very, very powerful mechanism that would let you do all kinds of different things. So going back to the code, as you can see then when we get this updated object handler, we just point our ball image to this particular coordinate, and that's how it happens. And the same thing is when we drag our image, we just update the attribute in that remote shared object. Okay, so here it is. This is the mouse move occurs in our Windows Phone 7. We create this point object and update the coordinates inside of the remote shared object. Okay, so that was the demo with RSO. So if you have any questions regarding this, then I'll be happy to answer. But that was the demo for remote shared objects. All right, let me clear out my desktop. Okay. All right. So next, let's move on and talk about server-to-client invocations. So server-to-client, just like with remote shared objects, it works with Java and .NET. And by the way, there's a question someone needs to leave, and they're asking where they can get the recording of this. The recording is going to be posted to our blog. It will coincide with the release of WebORB for .NET. More than likely, we'll just start a beta because most of the functionality is ready, and we're anxious to get it out so you guys can start playing with it. And as soon as it is released, which is not far from today, there's going to be a blog post on our blog, blog.themidnightcoders.com, or if you go to facebook.com/midnightcoders, you can get the updates from there. And then the videos of the recording of the webinar will be posted to our blog as well. Jay is asking the question, how does the server handle concurrent manipulations of that shared object? This is an excellent question. So there is a locking mechanism, and updates are handled in the same order that they arrive, and there is a concurrency control that enables us to make sure that the clients do not step onto each other. Every single update that occurs inside of WebORB on your shared object is associated with a particular version number. So the versioning is also there, and you can track, at what version what the values were. So that's definitely handled in the environments where you have a lot of concurrent clients. Okay, so going back to server-to-client invocations, as I said, it is applicable to Java and .NET. The APIs are almost identical, and as far as Windows Phone 7, you can easily invoke client-side functions directly from your, let's say, .NET or Java code. And this also works across different devices. So for this, what I'm going to do is I will start both my Windows Phone 7 application for the callbacks. All right. I'm going to close this browser because it's taking too much memory. All right, so this is my callback application, and right here, the code is ultra trivial. So as you can see, I'm connecting to my server, and this is my WebORB for .NET server, and I have a bunch of different methods. Now, all of these methods are invoked from the server-side code using the APIs that we have, and those APIs are actually in the doc. And whenever it happens, we just update the state, update some label. Actually, we have like a text box, and we put the messages in there that will say when the various clients connect and disconnect to that particular application. So this way, the server keeps all the clients informed as to who is connected and where, how many clients are there. So first of all, let me run this particular application. And the interface of this is going to be ultra trivial. So first of all, we're connected and we got our own client ID. And I'm not sure if you can see this, but right here in this little box, it says events, and this is the box that we will be updating as various clients come in and go out from the connection to that particular server. So first of all, let me bring up a Flex client once again. So right here, I can click on this link, and a new client is connected. And as you can see, this message right here says client connected, and it puts this ID of this client right there. So now if I disconnect client with ID 13, which happens, it says client disconnected. Okay, so this way we have Flex client and we have Windows Phone 7 client all receiving these messages. But something else that I wanted to show you that we are actively working on, we're also adding support for iOS. So exactly the same application is also available for iOS, and this way you can see that both iPhone and Windows Phone 7 can actually coexist and really communicate. So right here in this iPhone application, I'm going to connect to my host, which is 192.168.8.10. And the name of this application is, let me just check that, it is going to be callback demo. All right, so now we're connected. Now watch this as, so I have my Windows Phone 7, I have my iOS client. So now as I click on this particular link to add additional Flex clients, so here it is, client connected, and we get a notification, client connected ID 15 right here, and the same thing, client connected ID 15. Okay, and right here, just going to find this guy. So right here, if I click to disconnect this, you know, both of these got client disconnected, client disconnected. So this is really a demonstration of various devices being able to communicate with each other, including, you know, between iOS and Windows Phone 7. And this is really just the first step, and we're actively working on providing a full integration that is really cross-platform, so to speak. But it is done natively. So here for iOS, for example, we do have a native Objective-C component that enables the same kind of connectivity, just like we have a component that enables the same connectivity for Windows Phone 7. Okay, so so that's the demonstration of the server to client invocation. And once again, if there are any questions, I'll be happy to answer them as well. Okay, let me continue with my demo. All right, publish subscribe. So publish subscribe really falls into the messaging which we support. And if you're not familiar with the concept of publish subscribe, it really is just as straightforward as it sounds. So you can take a message and you can send it somewhere to the server, and that message is being published to either a queue or topic or somewhere that subscribers can get it from. The way WebORB enables this functionality is we provide support for a concept called destination. So think of a destination as really just a bucket, and a bucket that can accept messages, and as soon as a message is published, the WebORB will broadcast this message to all the subscribers. And that bucket, that destination, can also be linked with various message queuing systems, specifically the ones that are listed here: GMS, NMS, MSMQ, ActiveMQ. And what happens is if you were to link WebORB messaging destination with, let's say, MSMQ, then anytime you publish a message from your phone or from the server, WebORB will put that message into a corresponding MSMQ queue. And likewise, when a message arrives from that MSMQ queue, then WebORB will pick it up and deliver it to all the consumers. And once again, this works across all the clients which we support, including Flex, Flash, JavaScript, Silverlight, Android, and so on.